The mic on. Can everyone hear me? Yes. All the way in the back. Perfect. Excellent. All right, so my name is Steve Edwards, and I'm here to talk about implementing explicit allow without getting fired. So I work at Duo Security, which is now a part of Cisco Systems, and I lead their corporate security engineering and offensive security teams there. So a little bit of blue and a little bit of red. Before that, I was at Eastern Michigan University, where I led the security program there. At Duo, we have a really great product, and that's not what I'm here to talk to you about today. At Duo, we're allergic to vendor pitches, so I just wanted to tell you about some of the cool things that we're doing inside of Duo to keep the company secure. And then if you want to know more about our product, we do have a booth outside where you can stop and talk to us, and we'll give you all the details about it there. So you came to a presentation where the title included a phrase that I coined. So you may have never heard of explicit allow before. And essentially, it's a method by which all code, except that which has explicitly been, that has been previously seen, has been approved. Except which has been previously seen and approved is prevented from running on a system. So it's a more inclusive term for application whitelisting. And I didn't coin this phrase just because whitelisting and blacklisting can sometimes make people feel uncomfortable or excluded. But this allows us to expand beyond just application whitelisting, this principle, this concept. And so I think you'll see today why this might be a better term. So I'll take you through some of the ways that we've implemented explicit allow at Duo and the way that we did it where no one ran me out of town with pitchforks. So the first thing that I want to talk about, and the secret to our success, is design. And so I'll talk about design at Duo. And I will talk about our product a little bit because we spend a lot of time thinking about design. And I'll share how those design principles we applied to the tools that we built internal to keep the company secure. Then I'll talk through where we've applied explicit allow in practice. So on our Macs, our Windows computers, our Chrome OS computers, as well as at the network level, and also for some types of authentication. I'll share a little bit about what's coming next for the things that we're building. Then I'll have time for Q&A, and if I talk really, really fast, which I tend to, then we'll have time for a demo as well. So design at Duo. At Duo, we have a strong focus on usable security. And you can see that in our product. People actually like to interact with it. And so we've taken those principles of user-centric design and applied it to explicit allow. And that's the reason we could roll out something as restrictive as these principles without seeing a lot of backlash from our end users or our system administrators. So in this presentation, I'll show you some of the tools that we've built, explain the underlying infrastructure, and the philosophy that we took in our approach to implementing this at Duo. So in other words, if you don't have usable security, people will find a way around it. In this old Dilbert comic, Mordak, the preventer of information services, says, security is more important than usability. In a perfect world, no one would be able to use anything. And then this guy's logging into his computer, and it says, to complete the login procedure, please stare directly into the sun. That's a great example of non-usable security, but that's what security companies often ask of our end users. And it's a bad experience for them, and then it's a bad experience for security teams because they've implemented something that people hate. And so if security isn't usable, it won't work. People will find a way around it. If you implement something that's so hard, makes someone's laptop so hard to use, they'll bring a work-from-home laptop. Or if you make it so hard for them to get at their email, they'll just start forwarding it to another mailbox. And we can go back and forth and try and add more controls to make it even harder and harder and harder, but that's not enabling the business. That's not whatever your company is supposed to be doing. That's standing in the way of it instead of supporting the mission. So we wanted to take these principles and apply them to explicit allow. Duo's focus on usable security can be seen even in our staffing. At Duo, for every 5 software engineers, we have 1 product designer. So that's a lot of people thinking about how humans interact with computers and receiving feedback from people who actually use our software and people who buy and implement our software, what they like and what they don't like, and what's effective. Because honestly, that's what makes effective security. So we wanted to minimize friction. We wanted to protect people without ruining their day. And we wanted to protect people without ruining our IT department's day. If we're pushing out something to the laptops that IT manages, they're the ones who are going to get yelled at, not us. And maybe they're really good at redirecting it, and I still get yelled at. It happens sometimes. But we don't want to ruin our system administrator's day or our end user's day with any of the security that we roll out. We just want to introduce the right amount of friction when a risky action occurs. But make sure that it's not too little and too much. Just enough friction for someone to slow down and say, hey, is this really what I wanted to do? And at the same time, provide them with the best security that we can. So the winning formula, and we've applied this across all of our platforms, and I'll go through and I'll show you some examples of each. Say this starts when an action is blocked. So I feel like I'm playing Tron just a little bit. Yay! Okay, well, I liked the Tron sound effects, actually. Maybe I'll put that back later. Okay, so the winning formula is this. Any of these start when an action is blocked because, like I said, explicit allow is default deny. Everything is blocked at first. So say you try to run an application on your computer. You double-click on it, and some scary message comes up and says, hey, you can't do this. Talk to your system administrator, please. A local agent will send that event to automation, and then we can start doing things. In the background, we can use threat intelligence to start scanning, if this is scanning this application against our threat intelligence feeds to say, hey, is this known malicious right now? And if it is, we'll just raise an incident right away. It's blocked, so nothing bad has happened. It's already blocked, but we still want an incident because we don't want malware on our computers, even if it's not doing anything, because how did it get there? Maybe something else, maybe a dropper did end up getting through and landed the software there. But if we don't see that it's malicious right away, we'll prompt the end user and say, hey, did you intend to run this? Because typically we don't want software running on people's computer if they didn't mean to do it. Unless, like we, IT, pushed that to them, and then we'll have already added it to the allowed list. So we'll ask them, hey, did you mean to run this? And if they say yes, then okay. It's added to their allowed list right away, and they can double-click it, and it will run. If they say no, then we'll create an incident, and we'll work through why is software running without this person's permission. Maybe it's just the Adobe updater, and they don't sign their binaries, which is really frustrating. So they didn't know that Adobe was updating in the background, so they said, we didn't mean to run this. So that's a good start. And then every single day at around midnight, we go through our entire list of allowed software and rescan it against threat intelligence to see, hey, has something that was previously unknown been flagged as malicious? So then we can raise another incident and follow up if that's the case. And you can see with this formula, there's more that we can inject here. This is a great place to start, but you can also work in sandboxing, and you can work in actual system administrator authorization, all through this same workflow. So in practice, here's my Mac. I'm trying to run a piece of software called Stellarium. It lets you see where the stars are in the sky. And it's not allowed yet. So on Macs, using Santa, we see this pop up. And it looks really scary, and there's a lot of information. Not all of it I understand. And my only button is to click ignore. That's not a great experience. We didn't build that piece. And the next thing that happens is our friendly Slack security bot says, hey, Sedwards, we noticed that something was blocked from running on your machine. Our goal is to keep you safe while enabling you to do your job. Please direct any questions to the corporate security channel, but did you mean to run this application from this folder? If yes, then you'll be able to run it again. So if I click yes, it says, okay, the application's been added. So within the next 30 seconds, you should be able to run the application again. If that doesn't work, you can open up Terminal and type in this incantation, and then everything will work. If you have any problems, again, please reach out to us, and humans will help you. And so after that, I double-click the application again, and it opens right up. So the amount of friction that was introduced here was all of about 15 seconds. I saw a scary message, but at the same time, my friend's security bot was reaching out to me to see if this is something that I really wanted to do. And as soon as I clicked it, it was just about ready for me to, by the time I could switch back and find where I'd put the application, when I double-clicked it, it was ready to run again. So this started from humble beginnings. So here's the original approach, is we started with just having people see this pop-up and then take a screenshot and then also copy and paste out the SHA-256 hash because it'd be a pain for us to type it in from a screenshot and post it in a Slack channel and say, hey, I'm trying to run this. Can you please allow it? And then, we'll do the threat intelligence by hand, and then we'll get it in there, and so you can see, post the hash in, and so T. Soakley there went through and said, yep, that looks good. I've added it to the list. So now you can open up terminal and type in the sync command, which everyone knows how to do because they're doing it all the time every time they run new software. And then they're good to go. And somehow, we didn't lose our jobs for doing this because everyone was so supportive. I don't recommend starting with this approach. If you can start with the automated approach, that's probably a better option. So let me tell you a little bit about the technologies that we use for Explicit Allow. So you've seen macOS already. And on macOS, we use Google's open source project Santa. And we've been using it for a really long time, relatively speaking. When it was released as a client with no server. And there were no servers available for it. Eventually, there was an open source software called Zentrol that served as a backend for this. So it would actually at least maintain the list of allowed software so that you could centralize that. Without that, you would have to figure out a way to put the list of allowed software on every single person's workstation as well as the Santa client. So we did that for a little while. It was backed on Elasticsearch. My experience of Elasticsearch is it's hard to keep it healthy and running smoothly, and that was the experience in this case at least. So we decided to throw it out because of its poor performance and build something entirely homegrown that's API-driven, entirely serverless, and it's actually a really simple bit of software. It serves up the list of allowed software to everyone who asks for it. And you can add new things to that software. And then it can also trigger the automation to say, hey, this person saw this block event. Let them know that, ask them if they meant to run this software. So since that was such a smashing success, and we rolled it out across all of Duo, which is about maybe 800 Macs, we decided to focus on Windows. Not because we have a lot of Windows. We probably have about 10 Windows workstations. But because Windows is a target, and we do have 10 Windows workstations, so it seemed like a problem to solve. So instead of going for commercial software or even open source software, we looked within Windows to AppLocker, which my experience in the past with AppLocker has been, I don't want to say mixed, because I think that oversells the positivity. It was pretty terrible. AppLocker is really hard to manage, and historically has required an Active Directory. So for one of my engineers, I posed this problem. Like, I want to use AppLocker to enforce Explicit Allow, but we don't have an Active Directory. We don't want an Active Directory. What can we do? And also, I want it to be the exact same workflow that I showed you in that flowchart. I want it to only be about 15 seconds for someone to self-remediate if they get something blocked that they need to run to operate the business. So again, it was entirely homegrown, entirely serverless, no Active Directory required, and basically it's a small agent that looks through the Windows event logs for AppLocker blocks, and then without even using Slack, it just pops up a dialog and says, did you mean to run this, yes or no? And we've already scanned it against threat intelligence like VirusTotal, Threat Exchange, Cisco Tip, and seen that it's not known as malicious. And so we pop this up and say, did you mean to run this? They say yes, and they say, okay. It'll take about 30 seconds, and then you'll be ready to go. So here's an example. So this is like on the previous slide here, this blue thing is all you get with AppLocker by default. So completely useless, not even a way to say, hey, this is the thing I was trying to run. So we created a more verbose error message in case people need to screenshot it to us and share it with us. So we say, hey, did you intend to run this? And then if they click yes, it says, hey, please wait 2 to 5 minutes. It's usually much faster than that. And then they can run the software again. So this is essentially this small agent just shells out to PowerShell and interacts with local policy objects instead of using group policy orchestrator. It just changes the local policies for AppLocker. So it converts what we have in our database in AWS for what the allowed list is into the format that the policy is looking for and just pushes it in every 2 or so minutes. So Chrome OS. Chrome OS is a good place to start. If you're solving security problems on Chrome OS, you don't have a lot of other things that you need to be doing clearly. Because Chrome OS is such a hardened platform already. And so we are about 20% Chrome OS at Duo. And they're managed by G Suite, and they enforce trusted boot. But with G Suite for Chrome OS and also all of our Chrome browsers, we enforce explicit allow for plugins like Java and Flash and basically none of those, as well as Chrome extensions, and then on Chromebooks as well, because you can run Android apps within Chrome. We also enforce explicit allow for Android apps. So we manage all of that through the G Suite console. And it's manual for plugins because there are very few that people are asking for, and for Android apps as well, because honestly, although there's a huge Android app ecosystem, at Duo, very few people are actually asking for us to add new Android apps. So Chrome extensions are the highest volume. People want a new Chrome extension every day, and they're very hard to evaluate. So we created a tool to evaluate in a consistent way Chrome extensions. The team who's adding the Chrome extensions to our allowed list is our security operations team. Someone says, I want this Chrome extension. They email the security operations team. They say, hey, I want to run eBates so I can get all of that money back. And so the security operations team gets that, and they can see it in the Chrome Web Store, but that's really all they had before we built this tool. Chrome extensions are written in JavaScript. Our security operations team isn't necessarily JavaScript experts, but even if they were, we wouldn't really want them spending all of their days like taking apart a JavaScript Chrome extension to see what it's doing. Like the permissions are kind of easily available in a JSON file where you could look through and see, okay, well, this URL means that it needs access to everything, and this URL also means that it needs access to everything. But that's a complicated process. But even if everyone was an expert at doing all of that, and it didn't take them that much time, because they're all humans, they're all going to do it inconsistently. So we wanted to build a tool that allowed our security operations team to have a consistent and quantifiable reason for either approving or denying Chrome extensions when people ask for them to be allowed. So again, we built this entirely serverless on AWS Lambda. It's a React.js front end, and when we started, we decided, well, we could scan Chrome extensions one at a time, or we could just scan them all at once. And so we said, well, how many Chrome extensions is there? There's about 160,000 Chrome extensions in the Chrome Web Store. So we called up our friends at AWS and said, how many Lambdas can we run at once again? And we had a few discussions with them. And then finally we hit the go button, and we scanned all 160,000 Chrome extensions. And 5 minutes later, the tasks had completed, and we were like, well, what broke? But actually, we just scanned the entire Chrome Web Store in 5 minutes. And so since we've already scanned all of the extensions, we thought, well, why don't we just let everyone else see the reports too? So we made this a free SaaS tool that people can use. It's not open source. It wouldn't necessarily be a good idea for us to open source it. It's kind of aggressive against the Chrome Web Store. There aren't some APIs, so we've done some other things. Google's cool with that, but I don't think they would be cool with us open sourcing this and saying, hey, why doesn't everyone scan all 160,000 Chrome extensions in the Chrome Web Store every 3 hours? So we have it closed source, but it is API first because we wrote it in React. So if you don't like our tool, if you don't like our color scheme, we have API docs available as well. So this is something that's available to you today. You can go to crexcavator.io, which is crxcavator.io, and you can get started. So let me show you just one of the things that Excavator does. So take, for example, a Chrome extension like LastPass. We use LastPass at Duo. I'm a moderately big fan of LastPass. It's an important tool. Password vaults are an important tool, and they should exist as Chrome extensions. That being said, for a password vault to exist as a Chrome extension, it's going to need to be a little bit risky. So we scanned it with Excavator, and so at the top you can kind of see, okay, we pulled some stuff out of the Chrome Web Store. This is convenient to have at the top. Here's the picture. Here's the ratings and things like that. Nothing revolutionary. But down below you can see how we've quantified the risk of the Chrome extension and grouped it into certain categories. And I'll kind of take you through some of those categories. So at the very top, you can see that since we're scanning the Chrome Web Store every 3 hours, we know when the versions change, and we can actually plot, because we're quantifying the risk as a number, we can plot the change in risk over time. So you can see after the first version, and there's a funny story there, after the first version that we scanned, LastPass's risk score dropped quite a bit. And so moving on down the page, you can see the first thing that we're most interested in when it comes to Chrome extension risk, which is permissions. So we list out all of the permissions that the Chrome extension asks for, and we've quantified a risk value. This isn't super scientific. We sat down with Pizza and determined what are the worst permissions in terms of exposure that a Chrome extension could ask for, and then which ones are not as scary. Chrome extensions also have a principle of optional permissions, and we treat those exactly the same. If you're doing explicit allow and you're allowing a Chrome extension, then you have allowed the optional permissions. And whether or not your end users are asked to allow those later is irrelevant, because everyone will say, yes, I want to do whatever it is that you're asking me to do. So moving down the page, you'll see this retire.js vulnerability scan. If you haven't used retire before, it scans through JavaScript projects and looks for third-party libraries with known vulnerabilities. So it's just really simple static analysis, and we just put it out on the page and assign risk value to these as well. I have the caveat here. This is not in LastPass now. This is that first version in this line graph where their risk score was higher. And as soon as we built this tool, of course, the first extension we scanned was LastPass, and we said, hey, did you know that you have these 3 vulnerabilities from your third-party libraries in your Chrome extension? And they said, we did know that. We don't use those portions, the vulnerable portions of jQuery and jQuery UI dialog. So technically, we're OK, but we will patch this. And so we saw as soon as the next version came out, they did patch it. And now it's forever saved in history in Excavator. The next thing we look at is the content security policy. And that can restrict how the Chrome extension can talk to remote sites for a number of purposes. But the most interesting one is the connect source, because this can kind of tell you, is this Chrome extension standalone, or does it connect with a SaaS tool? Also, if you've set up an organizational account, which is free, you can add your virus total and Facebook Threat Exchange API keys, and you can scan all of the URLs in the content security policy to see if they're known bad. And you can also link to SSL Labs report. So if it is SaaS and you want to say, okay, well, like the host that this is probably connecting with is LastPass.com, so let's view the SSL Lab Score and make sure that it's A+, or however we want our password vault communicating with the password vault server. Moving down the page, it gets a little bit more technical the further we go down. We look for a list of all the other possible external communications, even if they're not listed in the content security policy. The current version, and by the way, I should say this is very beta right now. The current version is a simple regex that looks for things that look like URLs. Even if they're in the comments, we'll show it there. If they're broken apart by concatenation, we won't catch that. The next version that's coming out of Excavator will actually do AST parsing, where it will see what the JavaScript is actually connecting to, and we'll replace this with something a little bit better. Below, you can look at the manifest in all of its glory. You can also see if the Chrome extension is including external JavaScript files instead of actually packaging those JavaScript files in. And then we can also view entry points and dangerous functions. Below that, which apparently I don't have a screenshot of, we show everything that the Chrome Web Store says is a related Chrome extension. And again, if you've created an organizational account and you have an explicit allow list already, then not only will we show you the list of related extensions, but we'll cross-reference that against the extensions that you've already allowed. So that means that if someone says, hey, I want to run LastPass, you can actually look through and say, well, we don't have LastPass yet, but look, we have 1Password. We already have that exposure in our organization. Could you use 1Password instead of LastPass? So Excavator, if you set up an organizational account, you can maintain your list of allowed Chrome extensions. So you can see if something has been allowed or if it hasn't, and then cross-reference it with the similar extensions. You can enter your virus total and Facebook threat exchange keys to enrich the content security policy content. You can also deploy a Chrome extension to every device in your fleet, whether they're on Linux, Mac, Windows, or Chrome OS, and collect all of the Chrome extensions that they're currently running. This is useful whether or not you do explicit allow. If you don't do explicit allow, this is a great first step to say what Chrome extensions are in use today. And then you can start from there and say which of those are risky, and then build your allowed list. If you do explicit allow, then you can see what's the popularity. Like 500 people use this extension, only one person uses this extension, and it looks a little bit risky. Maybe we should actually get rid of it. But also, in either case, if you wake up in the morning and read that a very popular Chrome extension like Stylish was sold to a malicious third party and now it was stealing data, you can actually find out your exposure. You can say, hey, actually, we have Stylish installed on these 4 workstations, so let's go talk to those people. You can do this. You can do this with other tools. SCCM will tell you what Chrome extensions are installed. Jamf will tell you what Chrome extensions are installed. OS Query will tell you what Chrome extensions are installed. We built this because we have Chromebooks. But also, this is a really simple way to deploy this to a large fleet of various systems, like of various operating systems, and get a complete list across your entire fleet of what Chrome extensions are in use. Let's see. You can also, so if you have your list of either allowed Chrome extensions or your list of all of the Chrome extensions that are run from the gatherer fleet, we'll also sort those for you by highest risk Chrome extensions and most recently updated Chrome extensions with whatever the delta is to the risk score. And finally, if you have explicit allow enabled, we'll show you which Chrome extensions you have explicitly allowed that literally no one is running, so you can remove them from your exposure. So that's amazing, but why is it in this presentation? Everything is about my winning formula of how to support explicit allow, right? So we built that too. And so the Excavator Gatherer Chrome extension, the one that inventories your Chrome extensions, has another feature. So say I want to install the emoji unicorn theme new tab, which sounds totally legit. I go to the Chrome Web Store, and interestingly enough, Chrome extensions can't run on the Chrome Web Store. So I go to a Chrome Web Store, and as I'm going there, but before I go there, I see that my history has been updated, that I am going to the Chrome Web Store for a Chrome extension that has not yet been explicitly allowed. And so we pop up this notification that says, hey, you're about to see a page, and you're not going to be able to install the extension that's on that page. If I want to install it, I can click the pop-up, and I can go in and enter my business justification to say, hey, I want this emoji unicorn new tab theme because it looks totally awesome, and hit submit. And it says, okay, well, you'll be notified. So it's not quite the 30-second remediation yet. But then in the Excavator admin panel, if you have an organizational account, you can go in and see, hey, here's all of the list of the people who've requested these things. And then you can go through and check approved or denied. Big caveat, this looks like it does it for you. Google has not exposed the API to manage the Chrome extension allow list at this time. So this is just for tracking purposes. Your analyst or whoever's doing this will still have to also go into Google and say, hey, this has actually been allowed. So I talked a lot about software in terms of explicit allow, but if you think about it as a concept, there's a lot more things that you can apply it to. For example, networking. There's a lot of talk about zero trust networking or zero trust access. Duo's using that in its marketing now too. But it's something that we at Duo internally have been doing for at least 5 years now. And so essentially the principle is this. If you come to Duo's office and you connect to our Wi-Fi, you still don't have access to anything. Honestly, there aren't that many boxes that are on-prem. But even when there were more things on-prem, like a wiki or our code repository, things like that, after you got on the Wi-Fi, you still needed to get on a VPN before you could access anything. But moving that forward, moving that more to the explicit allow module, and here's the product pitch that I told you I wasn't going to give. We have a product called the Duo Network Gateway, which we originally built internally to solve a problem for us. And so essentially, instead of connecting to the VPN and then accessing the resources that you want, you just try to access the resources that you want. And if you're not signed in yet, you'll just be asked to sign in first. And in this process of signing in to the Duo Network Gateway, which is just an authenticated reverse proxy, once you sign in, it will figure out what applications you're authorized to access and wire up the networking for only those. So you have no network access to any of the systems inside Duo's network unless you're explicitly allowed access through the Duo Network Gateway. So this is like our modern approach on networking. Like in the old days, network security was really easy. In mainframes and consoles, your firewall was made out of cinder blocks, and it was pretty simple. But as people wanted to start working on the road and we got to client server and then cloud and mobile, it's really hard to put a firewall in the way of, in a useful position that protects all of your assets. And furthermore, it's difficult to gate access to all of the apps that you want your users to access because where your user might be going to a cloud service from off-prem. And so unless you have an agent on their workstation, and maybe they're using a mobile device, or an agent on the SaaS service, which is difficult to do unless it's at the time of authentication, it's really hard to actually get into that conversation and have a say in the security. The last thing that we're working on, so this is just a look at the future for us because I'll be honest, we're all friends here. The G Suite tenant that I use for Google Apps is absolutely haunted. I have more problems with my G Suite tenant than everyone else. And there was a new feature that was released a while ago to allow explicit allow for OAuth grants. And it has never worked in my tenant. I know lots of people who have been able to work with it, and just anything I try to do fails 500s, and no one at Google knew how to fix it. Well, we finally got it fixed, so we're gonna get back to this. But you may remember a while ago, let me see, it was 2 years ago, because I was on paternity leave for my second son, that there was this, mail worm that affected Google. So someone sent like a phishing email to a Gmail box, but instead of asking for a username and password, it presented them with an OAuth consent screen that just asks them to click allow to grant access to their contacts and to send mail on their behalf. And if you have an adversarial mindset and you haven't heard the story, you already know the rest. Once this program had access to all of the contents, it sent the same message to everyone else to spread more and more and more. And maybe there was something malicious that was supposed to happen as well, but it became so prevalent and widespread and newsworthy that Google was able to put a stop to it and revoke the keys to that client ID. But it raised a really interesting concern that OAuth is a type of authentication that we're not good at securing or teaching people how to keep secure. We get people into the anti-phishing mindset when they're asked for a password, probably. And we have lots of great tools like two-factor authentication and password managers that only autofill on the right site. But none of those really help you when you're presented with an OAuth consent screen for someone that you already do business with. And like where it says here, like Google API Explorer, because I was trying to get a screenshot really fast, wants to access your Google account. Like when you create an OAuth app, you can put whatever you want there. You can put Duo Security there. Please don't do that. Our lawyers will contact you. You can put whatever you want in that field, and there's no real validation. And look at the URL bar. It's HTTPS. It's accounts.google.com. It's all of the things that we tell our users to look for. But the blue authorize button, which I'm realizing now would have been great in this screenshot, is something that we don't have people sufficiently concerned about. And so we want to apply explicit allow to this as well. But again, Google gives us the ability to block unknown OAuth grants, but that's not a great experience. So like many things, you can solve it with a Chrome extension. So we've created a Chrome extension that actually looks for the OAuth consent block screen. So if we switch to explicit allow and it says, hey, sorry, you tried to do this, but it was blocked, then we'll actually get interesting information and send it to our automation to say, hey, this person tried to authorize this client ID, and here are the scopes that they were asking for. And those are the kind of things that you can find in Google Logs kind of already, not if they're blocked, but if they do authorize it. But that's missing a key thing. What is it? And with OAuth, that's a hard problem to solve because you can use a client ID in a number of locations. So we also, with this Chrome extension, capture the refer URI as well. So we can actually see what was it that sent you to this consent screen to actually authorize access. And with that, we have a complete enough picture to start running threat intelligence and say, okay, here's the risk we associate with send mail on my behalf, or view and edit all contents of Google Drive. And we can do threat intelligence against the refer URI to say, hey, this is the site that referred it. This is not a reputable site, or this is a reputable site. Or this is a site that we do business with. It's gone through our vendor assessment process. And so we can use that to enrich the content and have our security analysts be able to say, yes, this is okay to authorize, or no, it's not, but in a safe way. So if you're thinking about rolling out explicit allow, for anything that I talked about today or something else, there is a great way to start. And I'll tell you how we did it with Santa on Macs. But this is the process that we've applied to all of the things that I've talked about so far. If you're not in a brand new greenfield environment and you already have people who are running software on their computers, then deploy Santa in monitor mode to your entire fleet, or deploy Excavator Gatherer to your entire fleet, and get an entire inventory of everything that people are running. Don't go to IT and ask them what is the software that everyone is running. That will be an incomplete list. So deploy Santa, collect the entire list of software that's running, run that against threat intelligence and remove the obvious bad stuff, and then say, that's good enough. That is our explicit allow list. It might be 1,000 pieces of software. But that's a great place to start, because then the day that you turn it on, you do not lose your job. The CEO can still open PowerPoint. The CFO can still open Excel. And people can open their games, their Ableton mixer, whatever it is that they want to be doing that they'll be really mad if they can't do. They'll be able to do it on day one. And then on day two, when something new comes in, they get through the process. They start seeing the process of explicit allow and saying, hey, I want to run this new software, and I need security to evaluate it. And so maybe you can get to the place where we are, where it's automated, and the evaluation happens in real time for them, and they can get their own satisfaction within 30 seconds. But even if not, it's much easier to start with everything and work backwards than start with nothing and have everyone explicitly request access to everything that they want to run. Now for Santa, because obviously that still sounds a little bit terrible, right? For Santa and for AppLocker, you can explicitly allow based on the SHA-256 hash or the developer cert. So maybe do ask IT, hey, what software do you guys buy? And go through and find those developer certs, probably on your own computer. You'll probably see most of them. And say, okay, yep, so we'll authorize software from Adobe, from Cisco Systems, from Microsoft, from Apple, from whatever other companies that you're doing business with, so that even if those pieces of software update and the SHA-256 hash changes, people won't have to request access to run the same software that they have been requesting. If developers aren't signing their binaries, which let me tell you, a lot of developers don't sign their binaries, then it will be this process. And that's why it has to be this fast every time, because people are going to run into this a number of times. So I did statistics, and I'm thinking back, because again, this would have been great in my slide deck. I did statistics for my boss last quarter, And over the 3-month period, I think people interacted with the Mac explicit allow workflow about 600 times. So that's for 800 users, so maybe each person did it once per quarter, but I think it's more likely that several people did it a number of times a quarter, and then a lot of people didn't see it at all because they're not downloading new software, and other things are, the things that they're running have already been allowed. So there's just a few things left that we want to do on the things that we're working on. Specifically, like, we want to remove some of our external dependencies to make this more packaged, so maybe we could share it one day, or even just share it with other business units within Cisco. So like, we use Slack, and we have Slack integrated into some of this process. We have Zendesk integrated into some of this process. But since not everyone uses it, and maybe we won't always use it at Duo either, we want it to be entirely self-contained. So while the Santa process uses Slack to reach out with a security bot, the Windows process is just effective, where it's a pop-up dialog that says, hey, you tried to run this, yes or no. So that doesn't need to be Slack there. And then we just want to build it to scale. As Duo continues to grow, as we share the things that we've done with Cisco, we want this to be able to scale beyond what it's doing right now. So we'll continue to invest in doing it completely serverlessly with things like Lambda and serverless RDS. And when we have front ends, we'll do lightweight front ends like React.js, so we can just serve things out of S3. So let me stop here for questions, and then I totally have like a couple of minutes to show you a demo, unless we have a lot of questions, which will be even better. Yeah?
So maybe I missed it. The whole process, so when somebody gets that pop-up and they click it and it says try again in a few minutes, is that automated? It's going through threat intel?
Yes.
Okay.
So actually, probably before they've even seen the pop-up, we've already evaluated against threat intel, because we can do that fairly quickly because we don't do sandboxing. We do that, and as that's completing, the pop-up shows up on their computer. But since that only takes a few seconds, it seems to be instantaneously. As we start to explore how sandboxing works in this model, likely we'll actually still allow people to authorize it before the sandbox completes its run, depending on how long it takes, just so that we're enabling the business, even at the potential of having a few hours of exposure or something like that. But it's something that we can continue, because it's something that we built entirely ourselves. We can continue to fine-tune this workflow to whatever our risk appetite is at the time. Yeah?
You guys doing anything with web proxy?
Nope. I have not heard of web proxy.
No, I mean like Blue Coat or WebSense or anything like that, doing like just whitelisting approach on a web proxy.
Oh, so like inside a network, what sites people can access versus can't access? No, we don't do that. I think there's too many different things that people are trying to access. We want people to be able to access the games that they like and things like that. We do use umbrella OpenDNS, which is like the opposite, like blacklisting or explicit deny, where there is a list of URLs that just won't resolve because of umbrella. And so that's kind of the approach that we've taken there, just because it's such a broader, like orders of magnitude bigger than the number of applications that we run or Chrome extensions that we want to run is the number of websites that we want our company to be able to visit. Does that make sense? Cool. Yes?
Do you do feedback to Google about the results from your scanning, and have you considered posting those results?
For the Chrome extensions? So all of the results are posted. You can view all of them at excavator.io right now. We are not stating that a Chrome extension is malicious with Excavator. Google does a great job of actually gating that for the most part. You can tell because it's so newsworthy every time there is a malicious Chrome extension. I can think of 4 examples in history of malicious Chrome extensions that made the news. We're trying to show what the risk is if a Chrome extension is malicious, what it could do, and then businesses can, based on their risk appetite, determine whether or not that's acceptable. Like I showed LastPass, that's actually a high risk score in terms of total number of points. But the other part of the story is, I've been doing business with LastPass for years. I've seen them get breached, and I've seen through that how they handle that. I've signed NDAs with them. I've seen their SOC 2 audit. So there's a lot of compensating controls, especially when you're doing business with the company that makes the Chrome extension. So it's hard to say with the tool that we built, this Chrome extension is malicious. That being said, if you find a malicious Chrome extension, Excavator is a great way to figure out more about that malicious Chrome extension. Well, did you have another question? Okay. Yes.
On that Excavator,
Yeah.
if you sign up with an organizational account and you scan and you find what extension you're using, does that allow you to scan it on a consistent basis for updated? Or?
Yeah, absolutely. So there's a couple of ways you can do that. The first is you can continue to view those scan results via the API. We also expose an RSS feed, so you could actually follow the RSS feed for each Chrome extension to see as they change. But if you create the Excavator Enterprise account and sign in and go to your dashboard, and either you have the Gatherer extension deployed or you have a list of allowed extensions, then you'll see the list of your extension. You'll see which ones have updated recently and the delta in the risk score right there to say, hey, this just updated and the risk score went up by 500. That's worth looking at. Or this just updated but the risk score remained the same. So maybe you don't actually need to look at that one.
So Excavator automatically does that then?
Yeah, absolutely. Just because we have yesterday's report and today's report, so it's all we're doing is just comparing the numbers. Any other questions? Yeah.
A lot of the whitelisting is based on whether the user intended to run the app. How have you found that when they're just wrong? Like they just run malicious software thinking it was good?
So that is half of our defense, right? Is whether or not the user intended to run it. And certainly people will run MacKeeper or something like that, right? Because they want their Mac to go faster. I want my Mac to go faster. So that's why we have the additional data points of the threat intelligence. So those are the two things that have to pass before they go through. What we've actually found is a higher false negative rate where people are saying, I didn't mean to run that, and we're raising an incident. And then we're going and saying, oh yeah, well, I know you didn't mean to run that, but that's just Adobe trying to update Photoshop in the background or something like that, and there's an unsigned binary. Yes, one more.
Have you had any, you sound pretty data-driven. Have you been able to see kind of before and after data-wise on compromised machines?
Not especially. I think maybe Duo's too small of a company to have statistically significant results. Even beforehand, like a compromised machine, like I said, was probably just MacKeeper got installed or something like that. So I think our sample size is too small to show a meaningful trend. Any other questions? Yes?
Could this be adapted to Firefox?
The Chrome extension tool, could it be adapted to Firefox? I suppose so. I'm not going to pretend that I haven't been asked that question before. After we had a big launch of Excavator with press and things like that, people have asked about Firefox extensions. But like I said, the things that I've showed you today, I have built for my company, and we don't use Firefox. So maybe one day, but we have other things. We have other problems we want to solve first. Any other questions? Great. Well, I'm right at time, so thanks so much, everyone.